Okay, so now we're going to be looking at hydrate formulas. And hydrate formulas are going to be based on our notes that are on page 75 in our IMB. You can find the notes on Schoology, and the notes in Schoology are in color, which makes them a little more interesting to look at. Okay, so hydrates still follow our state standard of P.8.9, which deals with looking at formulas and what those formulas mean. And we have three focus questions. How do hydrates become anhydrates? What is the mole ratio needed to determine hydrate? And how do you name hydrates? Okay, so hydrates and anhydrates, that's our first most important piece, and that's the vocab for this section. A hydrate is a compound that has water attached in a specific ratio. So it's not just a compound with some water put in it. It's a compound that is attached when that water is attached in a specific ratio. So for example, for every one sodium chloride molecule, there are 3 water molecules attached to it. It's always done in ratio, and so that's our key there, is in ratio. We need to also know what an anhydrate is. An anhydrate is a hydrate that has had the water removed from it, so it becomes dry because that water has been left. Well, how do we take a hydrate and make it an anhydrate? We heat it. So if we have a hydrate and we add heat, the water leaves or evaporates and we're left with an anhydrate. If you take an anhydrate, a compound that has been dried out, and you leave it sitting on the counter overnight, it'll absorb water from the atmosphere and turn back into a hydrate, because the hydrate is the preferred or most stable form of the compound. Okay, so if we look at the picture here at the bottom, we have a hydrate. This is what we did in our lab today. We have a hydrate. We have the hydrate powder in the bottom of the crucible, and we heat it. So we know that there's water currently in the compound, but as we heat it, that water evaporates out. So what are we left with after the water has evaporated into the atmosphere? We're left with an anhydrate, and that's the compound without water. We're really focusing on the anhydrate and the water in order to be able to do our problems. So we have to use the mole ratio. Ignore the N there. We're using the mole ratio. So what we have to do is we have to find the moles of water and the moles of anhydrate. And we're going to do that from grams. So I have a little key up here to help us. The water is going to be the amount of hydrate minus the anhydrate. And the anhydrate is going to be the hydrate minus the water, which takes us back to the picture here. The amount of water is going to be the difference between the hydrate and the anhydrate. And the anhydrate is going to be the difference between the original hydrate and the water lost. And depending on the problem, we may have to use one or both of those equations. So we're going to find the moles of water, find the moles of anhydrate, and then we're going to do a ratio. And the ratio that we're going to do is we're going to take the moles of water divided by the moles of anhydrate, and that's going to give us our multiplier, just like we saw a little while ago when we were doing empirical and molecular formula. That is our ratio multiplier. So whenever we write the formula, we write the name of the compound times whatever that ratio was, N, H2O. And so that would say if my compound was copper sulfate and my N was a 3, I would say copper sulfate with 3 H2Os, meaning for every 1 copper sulfate, I'd have 3 water molecules attached to it. My last step is to name it, and I name it using those prefixes I used with covalent compounds. So I just said 3 as an example. So 3 would be tri. So we'd call it trihydrate, remembering that hydrate means water. Okay, so let's look at an example. The example that I have for the notes is a mass of 2.50 grams of CuSO4 is heated to reveal 1.59 grams of white powder remaining. What is the formula? Okay, so I know that I'm starting out with 2.50 grams of CuSO4, which is a hydrate. Okay, so that's my hydrate amount, and it leaves over 1.59 grams of white powder, meaning the water has been removed. So I have 2.5 grams of hydrate and 1.59 grams of anhydrate. I have to find the moles of water, find the moles of anhydrate. So I have to start with water. Well, I know that water means the hydrate minus the anhydrate. So I had 2.50 grams of hydrate, 1.59 grams of anhydrate, and when I subtract the two, I got 0.91 grams of water. Well, I had to take that 0.91 grams of water and turn it into moles. So I divide by the mass of H2O. Remember, H is 1.008 times 2 plus 15.999 for oxygen, and I got 18.015 grams in 1 mole. When I divide that out, I got 0.0505 moles of H2O. Now I have to do the same thing for anhydrate. Well, the way this problem was worded, I already know that 1.59 grams is my anhydrate or dry powder remaining. So 1.59 grams of CuSO4, which was my compound. So I have to divide it by the mass of CuSO4. So I had to take copper, which on the periodic table is 63.564, plus sulfur, which is 32.066, plus oxygen, which is 15.999, times 4, and I got 159.6. So I divide those out, and I got 0.00996 moles of CuSO4. So I have my moles of water, and I have my moles of anhydrate. Well, I find my ratio by dividing the two. So moles of water divided by moles of anhydrate, and I got 5.011. I round that to the nearest whole number. I get 5. So now I just plug 5 into my formula. CuSO4 with 5 waters attached. And when I name it, I say, well, CuSO4, Cu is a transition metal, so it's copper, but I'm going to have a Roman numeral. SO4 is sulfate. I know that SO4 has a charge of -2, so copper must have a charge of +2, so copper 2 sulfate, and that 5 prefix is pentahydrate. So copper 2 sulfate pentahydrate is my answer. I found the moles of water, found the moles of anhydrate, divided so that I got the ratio, used that ratio in my formula, the compound plus that many H2O, and then when I named it, I used the prefix for the number and then hydrate. Okay, so let's look at a couple of examples from your homework G. So homework G is going to be done on page 74 in your notebook, IMB 74. There are 5 problems, and we're just going to look at 1 or 2 of them. So I'll do problem number 1. Problem number 1 says a hydrate of magnesium sulfate has a mass of 13.52 grams. The sample is heated until no water remains. The anhydrate has a mass of 6.60 grams. Find the formula and the name of the hydrate. Okay, so here we go. Let's start. So with problem number 1, I need to know the water and the anhydrate. And I'm going to keep my notes handy so that I can figure that out. Okay, so for water, I read my problem and I see if it talks about a mass of water. It doesn't. It just tells me that no water remains. So I look back at my formula and I know that the water means the hydrate minus the anhydrate. Hydrate minus anhydrate. So let's look and let's see if we have the hydrate and the anhydrate. Well, I do. I know that the hydrate was 13.52 and I know the anhydrate is 6.60. So if I subtract the two of those, 13.52 minus 6.60, I get 6.92 grams of H2O, and I'm going to turn that into moles. So grams of H2O per 1 mole of H2O. Well, I'm going to get the grams from the periodic table. So that's 1.008 times 2 plus 15.999, and when I add all those up, I get 18.015. You're going to memorize this number because we're going to use it so many times. So 6.92 divided by 18.015 is going to give me 0.3841. I'm going to go to the 4th decimal place when I do these because it's going to help me make sure that my answer is the most exact. So I'm going to the 4th decimal place. Okay, so now I have to do the same thing for anhydrate. I know from my problem that the anhydrate mass is 6.60. So 6.60 grams, but it's of magnesium sulfate. Well, I have to know what the formula for magnesium sulfate is. It's going to require a little work. Magnesium is Mg and it's +2. Sulfate is SO4, and according to my periodic table, if I look on the back of my periodic table, SO4 is sulfate, has a -2 charge. Well, +2 and -2 cancel each other, so it's just MgSO4. Remember to always check your charges because these are going to be ionic compounds, so you're going to have to balance the charges out. These canceled, so it was just MgSO4. Okay, so grams of MgSO4 goes to the bottom, 1 mole on the top. So let's find the mass of MgSO4. Mg is 24.3050 coming from the periodic table. S is 32, so 24.305 plus 32.066 plus, And then I have to do 4 oxygens. So I'm going to take 15.999 times 4 in parentheses, and then add that to my Mg and my S, and I get 120.367. Okay, so I take 6.60 divided by 120.367, and I get 0.0548, again going to the 4th decimal place. Okay, so I have to take my water divided by my anhydrate. So 0.3841 divided by 0.0548. When I divide the two, I get 7, my whole number 7. So that's going to be my multiplier. So my formula then is going to be MgSO4 with 7 H2Os attached, and my compound would be called magnesium sulfate, and that 7 means heptahydrate. Okay, because remember hepta and then hydrate. So this is my answer. I found the grams of water, turned it into moles, found the grams of anhydrate, turned it into moles, took water divided by anhydrate, so I had 0.3841 divided by 0.0548. It gave me 7, so 7 then became my hydrate number. 7H2O, and that was heptahydrate. Magnesium sulfate heptahydrate. And also remember that I balanced my charges, so that I got my answer. Okay, I'm going to do one more problem just as an example. Okay, so let's look at number 3. Number 3 is worded a little differently, but it's the same process. It says a hydrate is determined to be 45.43% water and 54.54% COCl2. Find the chemical name and the formula of the hydrate. This one actually is easier because it gave me water, and this is the compound without the water, so this is going to be the anhydrate. And again, remember, I can just treat percentages like grams if I assume a 100-gram sample. So for number 3, I'm going to say that I have 45.43 grams of water, because remember I have to have water and anhydrate. So I have 45.43 grams of water. I turn that into moles. I've already memorized that water is 18.015 grams from its mass on the periodic table. And so when I divide that, 45.43 divided by 18.015 gives me 2.5218, remember 4th decimal place. And now I do the same thing for anhydrate. My compound is COCl2, so I have 54.57 grams of COCl2. I take the grams of COCl2 in a mole of it, and so I get those from the periodic table. CO is 58.933 plus, in parentheses, Cl, which is 35.453 times 2. And I get 129.839. So when I divide 54.57 divided by 129.839, I get 0.4203 to the 4th decimal place. So now I just divide water divided by anhydrate. So I divide the 2. 2.5218 divided by 0.4203, and I get 6. So that's my number that's going to go in. So I have COCl2 with 6 H2O. So I have to name that. That's cobalt. It's a transition element, so I have to put parentheses. Chloride is what I call Cl2. 6 is hexahydrate. Okay, so the only thing I have to fill in is my Roman numeral there. I know that chlorine, so if I have COCl2, I know that chlorine has a -1 charge, but there are 2 of them. So 2 -1s, and I have 1 of an unknown charge. Well, the only number that can fit there is a 2, so it must be cobalt 2, because 2 times 1 gives me 2, 1 times -1 gives me -2, so they balance. So my formula then is cobalt 2, or my name is cobalt 2 chloride hexahydrate. Okay, so if we can just recap to remember what we do for hydrates, we have to take the moles of water divided by the moles of anhydrate, and I have to do my conversion tables to get those. gives me my multiplier, and then I put that into my formula, and I just remember that if I get stuck, the hydrate minus the anhydrate gives me the water, and the anhydrate is the hydrate minus the water, and just focus on that.